সবাই মিলে বাজাতে হবে, তবে না তো আমরাও বাজাই।
হুম। Okay. Am I audible? Can you hear me? All of you?
Yes, sir.
Yes, sir.
Yes.
Okay. You should join this meeting using your actual name. Okay. Otherwise, I will remove the participant. Those who are not giving the exact name, so they cannot be joined in this meeting. Okay. So if anyone has renamed them, so they cannot join this meeting. So you must use your original name according to your registration card admit card, so that you can join this meeting. Otherwise you can't join this meeting. I will remove that person. Is it clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Don't use any other names except your original name which is given to the council. So I think one participant I have already removed, so he or she can join until he or she rename or use the original name. So Shreyoshi, are you there? Shreyoshi, Shreyoshi, are you there?
Also, I think the one whom you removed, that one was Shivsi, I think. The one you removed, because her name is different from what is being shown.
Okay, so I can't help it other until he or she can change his or her name. Okay, so let's start today's discussion, which is based on the instruction set. So last day Habibu given me some, or he has some queries, and he has told me that I have remained pending these instructions, like just a loop instruction. I think it is pending. Can you remember this?
স্যার ব্রাঞ্চিং এর পরে কিছুই তো হয়নি স্যার,
তো
ব্রাঞ্চিংটা তো
আগের
হয়নি
দিন যখন আমি জিজ্ঞেস করলাম তখন তো কেউ কিছু অ্যান্সার দিল না।
স্যার। আগের দিন আমি জয়েন হইতে পারিনি স্যার আগে।
তো বাকিরা?
এবার কেউ কিছু দেয়নি কেন সেটা আমি জানি।
Okay, so let's start with from this portion, loop instruction. So last was branching instruction. So conditional jump and unconditional jump has been discussed. After that, loop instruction is there. Okay, okay. Before this one, I will show you the list of instructions. These are the list of instructions. So I have completed up to branching instruction. Rest of the instructions still remain pending. Loop instructions, shift and rotate instruction, machine control instructions, flag manipulation instructions, and string instructions. Okay, so let's start from the loop instructions. Okay, so a loop instruction, basically these instructions are used to execute a certain operation which is related to the count value. Means one counter should okay, I will mute you all. So after delivering this lecture, we will ask you the doubts and queries. Until you have to mute yourself. So a loop instruction basically used in that section where you need to use the counter. So based on the counter value, certain operation you have to perform. Like you have used one counter value inside any register. Suppose it was happened in 8085 microprocessor. Like you have used MBI C, 05, then DCRC, then JNZ loop. So there must be some loop which will be operated according to your condition. So what is to be done in that position? You have to use one counter which will be decremented by one every time until it reaches 0. Okay, so that's why individually you have to use the decrement operation instruction and then check the flag status whether it has reached the final value, means the 0 value. So same thing can be happened here, but one extra advantage of having this loop instruction is you don't need to write the DCX or DCR, means you don't need to decrement your counter value individually. Okay, if loop instruction is used, that means whatever is loaded inside your count register, means CX register, if CX register stores some value like 50005, so if loop instruction is executed, then automatically the counter value which is loaded inside CX register will be decremented by 1 every time until it reaches 0 condition. You don't need to write DCX or DCCX. Okay, so you don't need to operate the counter individually. If loop instruction is used, automatically the CX value must be decremented by 1 every time until it reaches 0 condition. So there must be one unconditional loop instruction is available, like LOOP loop. So loop through the set of instructions until CX is 0. And another two conditions are based on the equal and or 0 flag condition. Okay, so these loop E or loop Z, loop NE or loop NZ, these two types of instructions are related to conditional loop instruction, and single LWP loop instruction is unconditional loop instruction. Okay, so LWPE means loop on equal until CX gets 0, or loop Z, which is called until 0 flag is 0, the loop will be continued. In the same way, if loop NE means not equal or not 0, loop NZ, loop not set the not the 0. So here the process will be repeated and the loop will be executed until CX gets 0 and 0 flag must be set. That means if if the 0 if the result is your 0, okay, the loop will be continued. So this loop instruction is very helpful so that you can minimize your instructions by using only loop instructions, so that CX register content will be decremented by 1 every time, and it goes in decrementing operation until it reaches 0 condition. Okay. Next is the shift and rotate instructions. These are very interesting instructions. So we have both shift instruction and rotate instructions. In 8085, it was only rotate instruction. There is no shift instructions. But in 8086, you have both of type instructions, so shift and rotate instructions. Okay, so first one is your shift instruction, which is called SHL or SAL, shift logical left or shift arithmetic left operation. So both the instructions shift each bit to left and places the MSB into carry flag, and LSB is made to 0. The destination can be a byte size or word size. Also, it can be a register or memory location. Number of shifts indicated by the count. Like you can write SAL AX comma 1. What does it mean? The accumulator AX content must be logically shifted, arithmetically shifted to the leftwise position by 1 time. Okay, so your count value will be written in this way: SAL AX comma 1. If it is given as SAL AX comma 2, means 2 times the rotate the shifting operation will be performed. Is it okay? So and SHL is the logical shift left, logical shift left. Both are both functions are same. Now here, how the shifting operation is to be performed. Suppose there is a content which is called 1010 1100 1010 0101, and if SHL is used, then how the bits can be shifted in this position, leftwise 1 bit position, D0 bit, this is D0 bit, this is D15 bit. Okay, so D0 bit goes to D1 bit, D1 bit goes to D2 bit. So in this way, leftwise shifting operation is to be performed, so that D15 bit, which is MSB bit, that must be shifted to the carry flag. And when every bits are shifted to the leftwise position, 1 bit position, the D0 bit will be vacant or empty, so that automatically 0 will be inserted into this position. Okay, so if shift logical shift operation is to be performed, or arithmetic shift operation leftwise position is performed, automatically the 0 will be inserted into the vacant position, that means in LSB bit position or D0 bit position. Whereas in case of SHR instruction, which is called logical shift in rightwise position, here the everything will be same, like it will be rotated in rightwise position, every bit will be rotated, so that D0 bit goes to carry bit, but D15 bit goes to D14 bit, and if D15 bit is vacant, automatically 0 will be inserted into this position. Okay, into this position, so that the shifting operation rightwise position can be implemented. Okay, and this can be written in this way: SHR, suppose this content 1010 1100 1010 and 0101 is loaded inside AX register, so that can be written in this form: SHR AX comma 1. So for one time rotation, if it is given as SHR AX comma 2, so 2 rotation will be performed. If it is given as SHR AX comma 3, so 3 times rotation will be there. Okay, shifting operation will be there, not the rotation. I'm sorry, that is the shifting operation will be implemented. Now the rotate instructions. Here, rotate instruction. Okay. Rotate instruction here in this case, rotate ROL, the function of this instruction is rotate the content leftwise position without carry. Okay, without carry, rotate without carry, leftwise position, ROL. And there has been one instruction which is called ROR, which is for rightwise rotation without carry. Without carry means carry is not to be shifted anywhere else. Here, like in this case, D0 bit, this is the bit positions 1010111101011101. This is D0 bit, and this is D15 bit. Okay, so a D0 bit moves to D1 bit, D1 bit moves to D2 bit. So in this way, D14 bit goes to D15 bit, and D15 bit goes to carry bit, as well as D15 bit goes to LSB bit also. Okay, so here D15 bit goes into 2 positions. One, it is going to the carry flag, as well as it is going to the D0 bit. Okay, so that is called the rotate instruction with leftwise position. And in case of rightwise position, what happened? Everything will be same. D15 bit will be goes into this position, D14 goes to D13. In this way, D0 bit goes to carry bit, as well as this D0 bit goes to MSB bit in this position, D15 bit. Okay, so both are same, only the difference is the leftwise position and rightwise position rotation. Now another is previous 2 instructions was based, these were based on the without carry rotation, but it is now RCR or RCL. These 2 types instructions are related to the with carry rotation, through carry rotation. How this through carry rotation will be implemented in this way: if it is based on the rightwise position rotation, then D15 bit goes to D14 bit, D14 bit goes to 13 bit, and in this way D0 bit goes to carry bit, and whatever is in your carry bit, that moves to D15 bit. Okay, that's why it is called through carry. So carry bit is shifted into new position. Okay, So carry is changed in this position, but what is your previous carry status, that bit should be stored in somewhere else, where is it is in MSB position, D15 bit position. Is it clear? Next is the RCL. RCL is here the right leftwise rotation is to be implemented, and when D0 bit goes to D1 bit and D1 bit goes to D2 bit, in this way the D15 bit goes to carry bit, and whatever be your what was your carry status, that moves into the D0 bit. Okay, so that is called the rotate instruction with through carry in leftwise position. Is it clear? Okay, so next instruction is your machine control instruction. According to this name, machine control instruction means to control the operation of certain function, means halt operation, like halt instruction. Why it is used? These are the machine control instructions: halt, NOP, wait, escape. All these are machine control instructions. Why? Because you don't need to transfer any content from any register to any register, or any register to memory location, or memory location can be shifted to anywhere else, or you don't need to operate any immediate data. So data is not used in this position. Only what happened, the machine must be controlled in such way that when halt instruction is used, it goes into halt state. No operation is to be performed. Now to exit from this halt state, you need to apply the reset signal into the processor. Until you press the reset button, or you don't have any you don't give any reset signal to the processor, you can't exit from the halt state. So it will be in ideal state. Okay, and the instruction is written in this way: HLT. Wait instruction, it is used to check the test bar pin whether it is low or high. So in according to the pin diagram of 8086, there is a pin which is called test bar pin, which is low level pin. If test bar pin is low, it's all right, the normal operation is going on. But if the test bar signal goes high, that means there have to be there is something speed mismatch, where microprocessor needs to wait for certain amount of time, and it waits the fourth cycle. Next 4 cycles it is waiting, and when the test bar pin goes low, after 4th cycle, the required number of executions can be further processed. Okay, escape instruction, ESC. Escape instruction is used to process the any coprocessor, to process the any signal from the coprocessor, like to give the bus access to the coprocessor. So it handles the operation using this instruction, escape instruction. Lock instruction, it is used to it is basically lock. It is used to don't give the full access to another master or another processor if it is in multiprocessor mode. Means if it is in maximum mode, you don't need to give the control of the buses to another master or another processor. That's why you have to lock them. And using this lock instruction, until this instruction is being executed, no bus can be accessed by another processor or another master. That's why lock instruction is used. NOP instruction is nothing it is no operation, only the instruction pointer will be incremented by 1 and nothing else. So no operation, it is basically used to create some delay into your timing diagram of the processor. T state, wait state has been inserted, TW is given, so every wait state can be inserted into the diagram, into the timing diagram, so that if any slow responding device is to be connected with the processor, and if that device is not ready to transfer or receive the data byte, then microprocessor has to wait for certain amount of time, and in that time basically it wastes the time, so that until within that time the required number of devices will be ready to accept or receive the data. So these are the machine control instructions. And next instruction is the flag manipulation instructions, where 3 flags are used, basically the carry flag, the direction flag, and the interrupt flag, so that you can handle more number of operations using these flags. As for example, you have direction flag. Now what is the function of direction flag? Direction flag, if it is 0, it goes into auto incrementing mode, so that memory locations will be incremented by 1, and if the direction flag is 1, memory location will be decremented by 1. So now to process any type of data in consecutive memory locations in incrementing order, you have to operate this direction flag, and that's why there are 2 instructions are available. One is to set the direction flag, means to make it 1, and clear the direction flag, which is used to make it 0. CLD, clear the direction flag, and STD, set the direction flag. If CLD is used, then the memory location will be operated in auto increment mode, and if STD is used, that means you have to use the memory location in auto decrement mode. Okay, STD, CD, direction flag will be 1. In the same way, carry flag can be manipulated. Like if you want to set the carry flag, there is a option. There is an option which is called the STC, set carry flag, or clear carry flag. Set carry flag means carry flag will be 1, and clear carry flag means carry flag will be 0. And this CMC means the complements of the carry flag. Okay, if it is 0, this will be 1, 1 will be 0, the complement of the carry flag status. And STI means set the interrupt flag, so that through INTR, any signal which is going through the INTR pin can be recognized. And CLI means clear the interrupt flag, so that every time microprocessor ignores the INTR interrupt request, it doesn't matter whether any signal is coming through this or not. Okay. It will not respond anyway if CLI is used. So basically these 3 instructions are based on the carry flag. Next 2 instructions are based on the direction flag, and the next 2 instructions are based on the interrupt flag. Okay, so these are flag manipulation instructions. So next is the string instructions. It's very powerful instructions. Like you have move SB and move SW instruction, means move the string byte. Suppose there are 2 strings in different memory locations. Basically these type of instructions are used in block shifting program. Means transfer a block of data from one memory to another memory position, where there are certain source locations are there, and you have to shift this data byte from source location to another destination location. So there are several destination locations. So here is your source location. You have to shift the data byte into another destination memory location. So both strings can be accessed using these instruction, which is move SB, move string byte, and move SW, which is move string word. Okay. So move string byte. If your data byte is 8-bit in size, then you have to use a move SB. If your data byte, those are stored in some memory locations, are in 16-bit form, 16-bit data byte is used, then you have to use a move SW. Okay, suppose in 4000 memory location, assume in 4000 source memory location, there is a data byte which is called 30. So now 30, that is the 8-bit data. And if you need to transfer the content from this 4000 memory location, so 30 will be moved from 4000 to another 5000 memory location. Assume 5000, that is your destination memory location. So in that case, you have to use move SB instruction, because your data byte 30 is 8-bit in size. If assume for move SW instruction, where it is used is, suppose in 4000 memory location you have 1000 data byte. At 1000, that is your 16-bit data, and this 1000 must be shifted from this 4000 memory location to 5000 memory location, whereas in 5000, that is your destination memory location. So your data byte is 16-bit in size, which is 1000, that must be shifted from 4000 to 5000, and the shifting operation will be implemented by move SW instruction, because this is called move string word. So 16-bit content, that is called one word. With that's why it is called move string word. Then there is a repeat instruction. Repeat, it's a prefix instruction. It cannot be used separately. Always, for any operation, like if you want to move certain string data bytes, or if you want to compare certain string data byte, so every time this moving operation will be continued until whole of the data. Suppose there are 5 data bytes has been transferred from one position to another position. So whole process will be continued. The moving operation will be continuously in it is operating. So now this is a continuous process. That's why repeatedly perform the same thing. And there is an instruction called repeat instruction. So if repeat instruction is given to the prefix of move SB or move SW instruction, so the move the string byte or move the string word can be accessed repeatedly. Okay, you don't need to access it individually, so that every time one data byte will be fetched from one position to another position, and then from one position to another position. You don't declare, whole of the data byte will be shifted. Along with, if repeat is used, you don't need to process the counter operation. Automatically counter will be decremented by 1 until it reaches 0 condition. Okay, so that is the function of repeat instruction. Repeat instruction always performs with the CX register. So your count value will be always stored inside CX register. Then count value, until the process is finished, every time the same operation will be repeatedly performed until CX gets 0. So your count value should be always stored inside CX register. Okay, and you don't need to operate DEC-CX counter. You can't, you don't need to write individual instruction to decrement the counter value. If REP is used, automatically CX will be decremented by 1. It's certain loop instruction function. Okay, but loop instruction is separate instruction. It can be given anywhere in your program, but REP instruction should be used with some other instruction. Okay, so REP, then you can write it as move SB or SW, because this REP always points to the next instruction. Okay, next instruction function. It is related to the next instruction function. And here is a load the string byte or load the string word pointed by SI register, that is to be used with this instruction. Next, the compare instruction. So you have compare instruction separately, but if you have 2 strings of data byte, one is storage from 4000 memory location to 4004, another string of data bytes are from 5000 to 5004. Now you have to compare both of strings, whether there is any mismatch or not. Okay, if all the data bytes are in both strings are equal or not. In that case, this string instructions, the compare instruction can be used. If the data bytes are 8-bit in size, you can write it as CMP-SB, and if it is used as your 16-bit of data byte, then this can be used as CMP-SW, which is called compare string word. Okay, so compare string byte and compare string word. Okay, so these are the instructions. Those are not discussed in previously. So if you have any queries, any doubts, you can ask me now. Okay. Do you have any queries, any doubts regarding the instructions I'm discussed right now? Do you have any queries, doubts? If you have, you can ask me. Anyone? Anyone? Do you have any queries, any doubts?
ঠিক আছে স্যার মোটামুটি।
Prosenjit, do you have any queries? Prosenjit? Orunavo. CMP instruction and repeat instruction. Okay, Orijit, wait instruction. Okay, I will discuss one by one. Please silent. First, wait instruction. Wait instruction. To understand the wait instruction, you must follow the pin diagram. Do you have book or anything else inside or in front of you? If you have, you can look at this picture of pin diagram of 8086, where there is a pin which is called test bar pin. So test bar pin is usually used to check whether the normal operation is going on or it is not synchronized with the other peripherals. Okay, if it is not synchronized with the other peripherals or with the other systems, then you have to then microprocessor needs to wait for certain amount of time, and that waiting stage can be implemented using the software method. Okay, and that's why wait instruction is there to check the test bar pin. Is it right? Is it clear? Then halt instruction, it is basically to enter into the halt state, means ideal state, no operation is to be performed. The basic difference between halt and NOP is both are used to maintain it in some halt position, means into some ideal state. Okay, it is not performing anything else. Now in halt there will be nothing can be operated, but in NOP instruction, if NOP instruction is there, in NOP no operation is there, and only instruction pointer IP should be incremented by one automatically, So basically NOP, no operation, it waits some of the time, wastage of time. Okay, and halt means you can't operate anything until you apply the reset signal, and when the reset signal is applied, everything will be cleared so that it will be started, the microprocessor starts its execution from the initial point. Okay, lock instruction basically used to prevent the or to preventing the gain of the system buses to the other processor. Like you have a maximum mode, in that maximum mode two processor can be involved. Now if one processor is performing